Hello guys, welcome back to my channel. Memo on African motifs. Are still working on engineering science N3. So basically we've got the question which is on forces from the question paper which was actually written in April 2021. So you just want to see how we're supposed to answer these questions that is on forces. So if you're new to my channel, you can consider being part of the family by subscribing so that you won't miss any of the classes that we shall be having from Memo on African motifs. So that was basically everything on this question here. So we just want to see how we were supposed to answer this typical question like this. All right, so the first part is on 3.1, where we were asked to name 3 principles that will be applicable if more than 3 coplanar forces act on an object and the object remains in equilibrium. Okay, what are the principles that can actually be applicable on a condition like that? Okay, so I've got these 3. In fact, there are more than 3, so you can just select from the ones that I'm having which one is going to be best for you. So I've got the first one: the vectors of the forces form a closed triangle. All right, the algebraic sum of the components of the forces in any direction is equal to 0. The algebraic sum of the moments of forces about any point is also equal to 0 there. All right. The lines of action of the forces meet at a point. So these ones, they're going to meet at a point, something like that. So as you can see, we've got more than, in fact, there are so many answers that you can actually use for this question. All right, so that's what we had there. And on 3.2, what is meant by the term equilibrium? So take note, you are referring to equilibrium there. What is that term? What does it mean? All right, so equilibrium, we know that it can be taken here. So this is where we are going to have our definition of the equilibrium. So let's start here. 2 or more forces acting on a point are in equilibrium. So now our definition is start here. When the point on which they act on is at rest and moving with constant velocity, where these 2 or more forces act on, where they, which means we are referring to these 2 or more forces which are above there. Okay, so I think this is pretty clear. You can cross-check from this information and see what you're actually having there, but that is the idea. All right, so let's see the calculations now that we are given there. All right, the first part we are given, determine the magnitude of force W and Q and force Q analytical, which means by calculation, not by using diagrams, but by calculation, that is analytical. If the system is in equilibrium as shown in Fig 2 below. All right, so this is the system that we are given here. But if you are to cross-check, the system that we are having is something else, guys. Look at these forces. This 100 Newton is facing to the point. W is also facing this side. Q is also facing the point where these forces are intersecting, which is not supposed to be the way. The forces should be from the point where they meet. They should be taken from that point, but in this case they meet at this point. So it's best for us to actually redraw this diagram so that we can actually attempt this question. Okay, so let's just have this diagram redrawn in a better way that we can actually use. Okay, so we're going to start with the horizontal line. So let's just put a dotted line here. All right, so on this part here we have got this dotted line. All right, which means there's nothing here, but there's a force here which is 160 Newton on the left side of the horizontal line. So that one is going to be indicated. So we're going to start with these ones. It's going to be easier for us. All right, so the 160 Newton here is going to be like this. All right, so this one is fine. There's nothing wrong about this one. So which ones do we want to correct? Okay, this one also is fine like this. There's nothing that is going to change, but the angle here, I want us to cross check here on the angle that we are given. The angle it should be between the force and the vertical and the horizontal line, but this one is between the force and the vertical line. So this is the angle that you're supposed to use here. This is the angle that we need, this one, not this 40 that is given. So we are going to find this angle, but we know that this is actually 90 degrees, this quadrant here, because these are quadrants. This is a quadrant, 90, another 90, another 90, another 90. So this is 90, 90, 90, or this quadrant like this. The quadrant is 90, 90, 90, 90, 90 degrees. So if this is 90 degrees like this, and here we've got 40 degrees, we are going to find this one. 90 minus 40, you subtract from 90 degrees, you are going to have 50 degrees there. All right, so this one is going to be 50 degrees. So let's represent this one of 50 degrees first. All right, so let's just say our vertical line is somewhere here. All right, I'm going to talk about that one. We just want to start with this one of 50 degrees. All right, so this one is going to be like this. I hope it's going to be clear, guys. I hope this is going to be clear. All right, something like this. Now this is the force that we are given here of 120 newtons. So this is 120 newtons, and we say the angle in between here is 50 degrees. So I want you to understand this, guys, when you're answering these questions. That's why I'm doing this, so that you actually understand the concept. All right, so this is your 50 degrees here. Let's move on to another force here. So this one was actually fine. So let's now correct the ones that we want to correct. These ones which are facing inside, sorry for that. These ones which are facing inside, this one which are facing the point, this 100, the Q and the W. Okay, so how are we going to do this? If we extend, what you're going to do is to extend this line. You extend that force that you're given. Okay, you just extend it like this. So I want you to see the concept. So you're going to extend this one of 100, this one. You extend this line like this. All right. So if you continue with this line, we have extended this line, which means this 100 is now at this point. This is now your 100 newtons at this point. But the angle now is going to be like this. All right. So take note the concept here. This is the line that you extended, which means this is now a straight line, and you also have this straight line. So using the concept of vertical opposite angles, you're going to see that this concept here of vertical opposite angles are equal. So this angle here that I'm indicating here of 20, because this is an angle of 20 degrees, this is 35 degrees. All right, so this is an angle of 20 degrees. So this angle is going to be equal to this one, because you have extended this, so it's going to be equal to this angle in between here. So this is 20 degrees here. All right, so if this is 20 degrees at this point, but remember, this is not the angle that we want to use. We want to use the angle that is between the force, because this is now your force of 100 newton. So we want to use the angle that is between this force and the horizontal line. Between it must be between the force and the horizontal line, but this one is between the force and the vertical line. So you're supposed to find this angle here, this one that I'm indicating here. Take note, this whole angle, that one. But we talked about this. We said this whole angle is 90 degrees. This complete angle is 90 degrees. So in order for you to find this one, it's going to be 90 minus 20, which is this angle now. So this whole angle is going to be 70 degrees. 90 minus 20, which is 70 degrees. Okay, so we shall have a force of 100 newton, which is at 70 degrees. All right, so let's have our force here. So we shall have something like this. As long it is before 90 degrees, it's fine. All right, so take note, this now is now bigger. Okay, anyways, that's it. But this is your 100 newton. So as we saw that, we said this is our 70 degrees now, this angle here. So this angle, take note, there's this one that we indicated, and then there's the bigger one. So this is the bigger angle, this one, from this point up to this point. So let me also indicate with an arrow here so that you can understand. So this is where your 70 starts in the horizontal line up to the force that you are given. So it must be between the force and the horizontal line. This is the horizontal line. Okay, so now you have 70 degrees there. So this one is now fine. All right, let's see another one. So we have corrected this one. So this one is no longer there. We have corrected it. We take this W is going direct upwards here because it's facing this way. It's supposed to be on top. So you're just going to take this W upwards. You just continue. Okay, this is what I'm saying, guys. You have to continue this line W. So if you continue with this line W, are you seeing that we are still having the vertical line, the one that we had? So that one is just going to be a vertical line, but now on top of the what? On top of the horizontal line. So it's going to be on top like this. So you have to correct this one. Okay. So when you have this diagram in this, it's going to be easier for you. Or there are so many ways that you can use, but that's the easiest way that you can do to have a redrawn diagram. So this is your W now, which is now on top. So it must face upwards. A force must be taken from the point going outwards like that. Okay. Or there can be a concept, if you don't want to redraw this diagram, we will talk about this in another class, that concept, so that you can choose which one is best for you. Okay. So Q, we extend it again because Q is facing inside and there's an angle of 35 degrees. So like I said, on a line like that, you just extend that line. Okay. So let's just extend this line like this. All right. So if we extend this line, I want you to see the concept here. We have got a vertical line, a horizontal line here. That's a horizontal line, and this diagonal line. So this angle is in between. That's your angle that you're going to take here from this concept of vertical opposite angles. So these are vertical opposite angles. So this angle is going to be 35 degrees here, but this is now your force Q at this point. All right. So Q is going to be seen on this side. It's going to be taken, or it's going to be reflected to this side here like this. So you haven't changed anything. It's still the same Q that you were given, and the angle that is between, because this angle of 35 is actually between the force. It's actually between the force and the horizontal line. So it's fine. There's nothing that we are going to change on this 35 degrees. Is going to be taken like that. All right. So this is now your force diagram that you understand in a better way. So when given this concept, how can we actually calculate? Because the question is to determine the magnitude of force W and force Q. So what are we going to do? All right. We have an upward force here, which is W. And we have got these downward forces which are in between here, because as you can cross check here, if you extend to form a triangle like this, you've got a downward force here. You also have a downward force at 100. We also have, if we extend this, we also have a downward force at 120 newtons. So we know that these ones, they are below. This is your reference axis. Okay, so this is your reference axis. So these ones which are below this reference axis, they are below in terms of being vertical, and this one, they are negative in terms of being vertical, and this one is positive in terms of being vertical. So those are the ones that you are referring as upward forces. Okay, as upward or downward forces. Okay, so upward or downward forces, represent, they actually represent vertical components. That is what I mean. That is what I mean actually here. These are vertical components, because you're talking about a force being upward or being downward like this. So this is a vertical line to the left or to the right that is being horizontal. Okay, so this is the concept that you're going to use. So which means you're going to work with vertical components. So how do we work with vertical components? Let's say this was 3.3. All right, we are at 3.3. So we are going to use this concept that upward forces F up is equal to F down. Okay, that is the summation. Actually, you just add them up. Okay, so let's just use the summation to add them up. So the sum of upward forces is equal to the downward forces. Okay, so which are the upward forces? This is your upward forces. So are you seeing now from the diagram, it's now clear that W is not a downward force because it was in this part, but it's an upward force. So W is equal to, that's the only force that we have in the upwards. Okay, and all these ones, they're in the downward. But 120, taking it back here, we are now referring to 120 sine because it's a vertical component. So it's 120 sine 150. So don't worry about the positive negative in this case because we are saying they are equal and the force can only be positive. So don't focus with the positive or being negative. Okay, so this one is going to be 120 sine the angle that is between, which is sine 50. So you've got 120 sine 50. Remember, vertical components, we say these are vertical components, these ones, vertical components, they take sine theta, which is sine of the angle. All right, we move on to 110 sine the angle that is between 110 is 70 degrees. So it's 110 plus 110 sine 70. So like I said, when these are equal, don't worry about the positive or negative because the force is always positive. Okay, then if you are working with the magnitude, okay, the magnitude of a force is positive, then this is Q sine 35, that's Q, and we've got sine 35 in this case. Okay, so we've got plus Q sine 35 degrees. All right, so this is what you're going to have. So you formulated an equation. Actually, that's an equation for W that you have, so we can refer to this as our equation 1. Okay, maybe we can have something on equation 2. So let's move on to equation 2. So this one, we just formulated it using upward and downward forces. Okay, so equation 2, we are going to formulate equation 2 from the left forces, the ones on the left side, because as we can see, this is a vertical line, and from this vertical line we have got forces which are on the left and we've got forces which are on the right. All right, so we're going to use the same concept, F right or is equal to F left. All right, the forces on the left, the sum is equal to the forces on the right. All right, so how are we going to take these forces? On the left side, what do we have on the left side? We are talking about this. So this is actually a horizontal line. So these are horizontal components. All right, so these are horizontal components. All right, so if we now understand that these are horizontal components, which means we know that we are going to work with cos theta this time. All right, so let's take these ones on the left. So since we are saying they are equal, there's no need of you writing negative or positive, okay, because we know that the right can never be positive, can never be negative, the left can never be positive. So that's why we are ignoring that part, because I hope you understand, guys. If we say what is on the right is what is equal, how is it possible? If there is positive 5 on the right, on the left is going to be negative 5. What you are talking about is the magnitude. That is why you don't focus with the sign. You're talking about the equivalent in magnitude. All right, so horizontal component of 120. Okay, so let's start. We've got 160 first here. Sorry, already it's in the, do you see that we didn't mention this 160 when we were working with the vertical components because it's in the horizontal. This one is the one that is in the vertical, but this time we are going to focus with it because it's in the horizontal, and it's on the left side. So you're going to take it, 160 is on the left, okay, plus another one on the left. We have got this 120 back to the horizontal, so it's going to be 120 here, cos, so it's going to be 120 cos 50 degrees. Remember the angle between of 120, it's 50, so it's now just using cos, so it's 120 cos of 50 degrees plus another one still on the left side because we are guided by this vertical line. So this 100 is still on the left side, so it's 100 back to this line, in this line horizontal, so it's 100 cos the angle that is between, which is 70 degrees. So you've got 100 cos 70 degrees. So take note the way that you're going to take these forces. All right, so we are done with the forces on the left side. As you can see, we do not have, we only had 1, 2, 3 on the left side, and we are using this concept that this one is already a horizontal, so it's just going to be taken as it is. But this one, there's an angle, that is why we use 120 cos 50, also 100 cos 70, because there is an angle between that force to the horizontal line, and whatever that is in the horizontal line, it uses cos theta. All right, so on the left you are done. Let's move on to the right. So to the right you have got Q, which is going to be taken in the horizontal. There's an angle between Q and the horizontal line, so it's going to be Q cos 35 degrees, which is the angle between, like this. All right, so as we can see, we have formulated equation 2 here. So now we have our equation 2. So cross-checking on the analysis here, we are going to find out that it's difficult for us to work with equation 1. Why? Because we've got two unknown values, W and Q. But working with equation 2, we can see that we only have one unknown value, which is Q. So you can solve for Q. Why? Because we can combine these together. All right, so let's try and combine these together and see what you're going to have. So it depends actually with the way that you are going to combine these values, but combining these values, I obtained something like 271, 336,527, something like that, which is equal to Q cos 35 degrees, like that. All right, so if you are to cross-check actually here, we can divide actually this by cos, which is cos 35 degrees. Okay, so this whole part divide by cos 35. So now the way that you're going to divide actually is going to affect even your answers. So that one is not a worry, but just know that it's going to affect your answers. Okay, so let's divide by cos 35 degrees here, divide by cos 35 degrees, like this. So cancel this part, so which means your Q is going to be, so it depends with, if you round it off here, your answer is going to be different, but use that answer as it is. Okay, so from me here I obtained, because I just divided the answer that I had, as just said, answer divided by cos 35, I obtained something like 331,2407376, yeah, something like that. Then round off to 3 decimal places, depending with the degree of accuracy that you want also. So to 3 decimal places, this is going to be 331, we've got 1, 2, 3. So 7 is going to change this 0 into 1, so it's 241. Okay, and this Q is actually representing a force, and all these forces, they were in newtons. So this Q is going to be this force in newtons. So that was the idea there. So we took advantage of this equation because we only had one unknown value, so you can take advantage of that one unknown value, which is Q. You calculate the value of Q. So like I was saying, guys, it's actually a negative that we are supposed to obtain, but the Q that we are talking about, we know from the diagram, yes, it's in the negative region, but we just need the magnitude, just like these ones. It was 100. We never wrote this as minus 100 or minus 120. It's written as 100. So it's the same thing. That is why we didn't focus with the signs. Okay, so let's see. Now we have got Q. So using equation 1, I can substitute here the value of Q so that I can obtain the value of W from equation 1. So that will be W is equal to 120 sine 50 degrees plus 110 sine 70 degrees plus the value of Q that I obtained here, which is 331,241. That's 241 sine 35 degrees. All right, so this is a matter of using your calculator properly here. Just evaluate everything as it is. That is the display that you're supposed to have from your calculator. So because I didn't round off my answers like with another degree of accuracy, I'm going to obtain something like 375,866,276. All right, so the degree of accuracy again, I'm going to round off this maybe to 3 decimal places, just like what I did. So it's going to be 375, comma, we've got 1, 2, 3. So this is going to change into 887, which is in newtons. So that is the concept there. So you've got the magnitude of the force W and also the magnitude of the force Q. That is how we were supposed to answer this question. So we had to formulate equations using upward, sum of upward force and equal to downward forces, and also the sum of the forces to the left should be equal to the sum of the forces to the right. So using this concept, you formulate equations, you solve them using any concept that you know, using your your mathematical skills there. So you're actually applying your mathematical skills to solve these equations. The topic of forces will be done. All right, so on 3.4, calculate the magnitude of the unknown force. Okay, so we have got this unknown force here, which is F. If I'm to cross-check here, there is something that is weird here. We have a force and a certain distance. I want you to look, cross-check the direction. The force given this way, the distance given this way. Now the distance given this way, which means our force should be given in this way. So this is the force that you're supposed to have. But take note, there's an angle of inclination here, of incline, which is 60 degrees. So you're supposed to find this force here is the one that you want, and it's a vertical component. So this one is going to be, if it is a vertical component, it's going to be F sine 60 degrees. All right, so this is the force that you're talking about. Just like this, we are given horizontal, vertical distance. So here we are given horizontal distance, vertical force. That is the concept there. All right. So what are we actually going to do? We now know that force, but how is it going to help us if we know that it's F sine theta? Okay, this is what we're going to do. We are going to apply the concept of the moment, because we know that we are given the force and the distance there. So applying the concept of the moments, we can actually multiply the force and the distance in between there. All right, so let's just remove this part here. So on the left side here, we just refer, because this is a vertical line just like what we had here. So you've got the left side and the right side. Okay, so that is a 3.4. So you've got moments, so you're going to apply moments here on the left side moments to be equal to the right side moments. Okay, anyway, like something like that. So but we know that the moment that you are talking about is actually from the force times distance. So you're going to use the ones on the left. So this is the force on the left times the distance on the left, the force on the right times the distance which is on the right. So you can actually it's just force times distance. I hope you understand what I'm saying. All right, so since it is force times distance, on the left we've got the force here, which is 30, and the distance of 120 meters. So you can multiply 300, that's 300, sorry, by 120. So you've got 300 by 120, that's force times distance, which is equivalent to the force here. This is your force now, and this is the distance. So the force is F sine 60. Okay, so you've got F sine 60 from the one that we are saying. I think you understand from what I was saying that it opposes the one that we are given here. A horizontal here should be vertical, the distance vertical, the distance horizontal. So it opposes what it was here, opposes what it was here. So that's the concept there. It was a horizontal, this time a vertical. It was a horizontal, this time vertical, something like that. All right, so times the distance we have got 250. So you multiply by 250 like that. All right, so what are we going to have? So you can simplify, multiply these two together, you're going to obtain 36,000, which is equal to, then you can multiply these two together, sine 60 times 250, or 250 times sine 60, which is going to give you something like 216,506, something like that, times f. All right, so what am I going to do to find f? I'm going to divide by this value because it's multiplying, so I'm going to divide. So this is what you're supposed to have from your calculator. Okay, you divide this, so this is the part that is going to remain from your calculator. Okay, so using this concept, your f is going to be something like 166.2768, yeah, something like that. That decimal going and going and going. So I can round off to 3 decimal places. That's 1, 2, 3, which is 166,27. This 8 gonna change this 6 into 7. All right, so the one that we had, it was in newtons, so this one is supposed to be in newtons. Okay, so take note, we had a force there which was actually measured in newtons from the one that we're given, this one. So which means also this one is supposed to be measured in newtons. That is why we are having this in newtons. Okay, so that is the magnitude of the force F, the one that we are given from this concept. So as you can see, guys, they are actually different typical questions, very different in the manner that they are going to ask these questions. So what you actually need is to revise on those areas that should be given, that are going to be the best, because they ask in different manners. So that's it, guys, from Amazon African Motives, working on engineering science N3, still on engineering science N3. So please, guys, if you are new to my channel and you've been watching the classes and they have something that you are learning from it, please just become part of the family by subscribing, so that we grow our family. And also don't forget to share our videos to your friends and colleagues. Help someone outside there, help someone outside there. So that's it, guys, from Amazon African Motives. Till we meet again.